1. Introduction to Mercury. Mercury, named after the Roman messenger god, is the smallest and innermost planet in our solar system, nestled closest to the Sun. Its proximity to the Sun places it in a unique position, with scorching daytime temperatures that can soar up to around 800 degrees Fahrenheit, 427 degrees Celsius, and frigid nighttime temperatures plummeting to about -290 degrees Fahrenheit, -180 degrees Celsius. This extreme temperature range makes Mercury a fascinating celestial body to study. One of the most striking features of Mercury is its size. It is only slightly larger than Earth's moon. Despite its small size, Mercury boasts a dense composition, primarily made up of rock and metal. Its surface is heavily cratered, resembling the moon, with vast plains, scarps, cliffs, and impact craters dotting its landscape. Mercury's orbit is highly eccentric, meaning it has a significant elliptical path around the Sun. This eccentricity leads to a substantial variation in its distance from the Sun during its orbit, contributing to the extreme temperature differentials experienced on the planet. Studying Mercury provides valuable insights into planetary formation and evolution, as well as the dynamics of rocky planets in close proximity to their parent stars. Despite its challenges for exploration due to its proximity to the Sun, several spacecraft missions have successfully explored Mercury, unraveling many mysteries about this intriguing world. 2. Physical characteristics. Mercury's physical characteristics offer a unique glimpse into the diversity of planetary bodies in our solar system. Here are some key aspects. Size and mass. Mercury is the smallest planet in the solar system, with a diameter of about 4,880 kilometers, 3,032 miles, roughly 38% the size of Earth. Despite its small size, it has a relatively high density, indicating a large metallic core. Surface features. Mercury's surface is heavily cratered, resembling the Moon. It also has vast plains, cliffs known as scarps, and complex geological formations. The Caloris Basin is one of its most prominent features, a large impact crater over 1,550 kilometers, 963 miles, in diameter. Composition. Mercury's composition is predominantly rocky, with a metallic core that makes up about 70% of its mass. This core is thought to be rich in iron and nickel, contributing to its high density and magnetic field. Temperature extremes. Due to its proximity to the Sun and lack of a significant atmosphere to regulate temperature, Mercury experiences extreme temperature variations. Daytime temperatures can reach up to 800 degrees Fahrenheit, 427 degrees Celsius, while nighttime temperatures drop drastically to around -290 degrees Fahrenheit, -180 degrees Celsius. Gravity. Despite its small size, Mercury has a gravitational pull about 38% that of Earth's, which impacts its surface features and geological processes. Magnetic field. Mercury has a global magnetic field, although it is much weaker than Earth's. This magnetic field interacts with the solar wind, creating a magnetosphere around the planet. Understanding Mercury's physical characteristics is crucial for unraveling its geological history, formation processes, and its role in the broader context of planetary evolution in our solar system. 3. Orbit and rotation. Mercury's orbit and rotation are intriguing aspects that set it apart from other planets in our solar system. Here's a closer look at these orbital and rotational characteristics. Orbit. Mercury follows an elliptical orbit around the Sun, making it the most eccentric orbit of all the planets. Its average distance from the Sun is about 57.9 million kilometers, 36 million miles, but this distance varies due to its elliptical path, ranging from approximately 46 million kilometers, 29 million miles, at its closest point, perihelion, to about 69.8 million kilometers, 43.4 million miles, at its farthest point, aphelion. Orbital period, a year on Mercury, defined as one complete orbit around the Sun, lasts about 88 Earth days. However, due to its eccentric orbit, its orbital speed varies, leading to variations in its orbital period. Rotation. Mercury's rotation is unique in that it has a slow rotation rate but completes 3 rotations about its axis for every 2 orbits around the Sunday. This phenomenon is known as a 3-to spin orbit resonance. As a result, a day on Mercury, from one sunrise to the next, lasts approximately 176 Earth days. Axial tilt. Mercury has a very small axial tilt, only about 0.034 degrees, making its rotational axis nearly perpendicular to its orbital plane. This minimal tilt contributes to the lack of significant seasonal variations on the planet. Libration. Due to its eccentric orbit and spin-orbit resonance, Mercury exhibits a form of libration, where observers on its surface can see slightly more than half of its surface over time. Understanding Mercury's orbital dynamics and rotational behavior provides valuable insights into the mechanics of planetary orbits, resonance phenomena, and the influence of these factors on the planet's climate and geological processes. 4. Surface features. Mercury's surface is a rugged and fascinating terrain that reflects its complex geological history. Here are some of the notable surface features found on the planet. Craters. Mercury's surface is heavily cratered, resembling the Moon in many ways. These impact craters range in size from small pits to large basins, with the Caloris Basin being the most prominent. Caloris is a vast impact crater about 1,550 kilometers, 963 miles, in diameter, surrounded by rugged terrain and characterized by concentric rings. Plains. Alongside the craters, Mercury has extensive plains known as smooth plains or intercrater plains. These areas are relatively flat and lack the rugged topography seen in cratered regions. Smooth plains are believed to have formed from volcanic activity or impact-related processes that resurfaced older terrains. Scarps. Cliffs. Mercury features long, steep cliffs called scarps that can stretch for hundreds of kilometers. These scarps are thought to have formed due to the planet's contraction as its core cooled and solidified, causing the crust to shrink and fracture. Ridges and wrinkle ridges. Another distinctive feature on Mercury's surface is the presence of ridges and wrinkle ridges. These formations are believed to result from tectonic activity, where the planet's crust has been pushed together or compressed, creating raised structures. Impact basins. In addition to individual craters, Mercury has several large impact basins, such as the aforementioned Caloris Basin. These basins are remnants of ancient impacts that have shaped the planet's surface over billions of years. Volcanic features. While less prominent than on other planets like Mars or Earth, Mercury does exhibit volcanic features such as volcanic plains and volcanic vents. These volcanic activities are thought to have contributed to the planet's surface composition and geological diversity. Studying Mercury's surface features provides valuable insights into its geological evolution, impact history, and the processes that have shaped rocky planets in our solar system. 5. Atmosphere and Magnetosphere. Mercury's atmosphere and magnetosphere present intriguing contrasts and challenges compared to other planets in our solar system. Here's an overview of these two aspects. Atmosphere. Mercury has an extremely thin and tenuous atmosphere, often referred to as an exosphere. This exosphere is primarily composed of oxygen, sodium, hydrogen, helium, and trace amounts of other gases. The low gravity of Mercury makes it difficult for the planet to retain a substantial atmosphere, leading to its sparse and wispy exosphere. Surface interaction. Due to its thin atmosphere, Mercury's surface is directly exposed to the harsh conditions of space, including solar radiation and micrometeoroid impacts. This exposure contributes to the dynamic processes shaping the planet's surface features and composition. Magnetosphere. Despite its small size and thin atmosphere, Mercury possesses a global magnetic field, making it one of the few terrestrial planets with a magnetosphere. However, Mercury's magnetic field is significantly weaker than Earth's, about 1% of Earth's strength at the equator. Origin of the magnetic field. Scientists believe that Mercury's magnetic field is generated by a dynamo process within its molten iron-rich core. This process produces a magnetic field that extends around the planet, forming its magnetosphere. Interaction with solar wind. Mercury's magnetosphere interacts with the solar wind, the stream of charged particles emanating from the Sun. This interaction forms a magnetospheric cavity around the planet, altering the behavior of solar wind particles near Mercury and influencing its space environment. Understanding Mercury's thin atmosphere and unique magnetosphere provides valuable insights into planetary atmospheres, magnetism, and the interactions between celestial bodies and the space environment. These aspects also play a crucial role in shaping Mercury's surface conditions and space weather near the planet. 6. Missions to Mercury. Missions to Mercury have been crucial in expanding our knowledge about this enigmatic planet and unraveling its mysteries. Here are some notable missions dedicated to studying Mercury. Mariner 10, 1974 to 1975. Mariner 10 was the first spacecraft to visit Mercury, conducting 3 flybys in 1974 and 1975. It provided the first close-up images of the planet's surface and gathered valuable data on its composition, magnetic field, and geology. Messenger 2004 to 2015. The Mercury surface, space environment, geochemistry, and ranging Messenger mission, launched by NASA in 2004, became the first spacecraft to orbit Mercury in 2011. It conducted comprehensive observations of the planet's surface, atmosphere, magnetosphere, and interior structure, greatly advancing our understanding of Mercury's history and evolution. Columbo, launched in 2018. Columbo is a joint mission between the European Space Agency (ESA) and the Japan Aerospace Exploration Agency (JAXA). It was launched in 2018 with the goal of further studying Mercury's surface, magnetosphere, and interior structure. Columbo consists of 2 orbiters, one provided by ESA and the other by JAXA, equipped with a range of scientific instruments. Future missions. Several future missions are planned to continue exploring Mercury. These include NASA's Mercury Polarimetric Imaging and Spectroscopy, Mercury Pi mission, which aims to study the planet's surface composition and geology, and ESA's Comet Interceptor mission, which will include observations of Mercury during its journey to study a comet. These missions have collectively revolutionized our understanding of Mercury, shedding light on its geological history, surface features, atmosphere, magnetosphere, and more. Continued exploration and study of this intriguing planet promise to unveil even more secrets in the future. 7. Potential for future exploration. The future holds exciting possibilities for further exploration of Mercury, offering opportunities to deepen our understanding of this fascinating planet and unlock new discoveries. Here are some avenues and potential missions for future exploration. Enhanced orbital studies. Continued orbital missions around Mercury can provide detailed observations of its surface features, geological processes, and variations in its magnetic field. Advanced imaging and spectroscopic techniques could unveil hidden details about the planet's composition and history. Surface sample return. A future mission could focus on collecting samples from Mercury's surface and returning them to Earth for detailed analysis. This could offer invaluable insights into the planet's geological evolution, impact history, and potential for past or present signs of life. In situ measurements. Deploying landers or rovers to Mercury's surface could enable in situ measurements of key parameters such as surface temperature variations, mineralogy, seismic activity, and interactions with the thin exosphere. These measurements would enhance our understanding of surface dynamics and environmental conditions. Magnetic field studies. Investigating the dynamics of Mercury's magnetic field and its interaction with the solar wind could provide crucial data for understanding planetary magnetism and space weather effects on rocky planets. International collaborations. Collaborative efforts between space agencies worldwide, such as NASA, ESA, JAXA, and others, can facilitate joint missions with complementary objectives, optimizing resources and expertise for comprehensive exploration of Mercury. Technological advances. Advancements in spacecraft design, propulsion systems, instrumentation, and autonomous exploration capabilities will enable more ambitious and efficient missions to Mercury, overcoming technical challenges and expanding our exploration capabilities. As technology advances and scientific curiosity drives exploration, the potential for future missions to Mercury is promising, with the prospect of unveiling further mysteries about this dynamic and intriguing planet. 8. Conclusion. Mercury stands as a captivating world that continues to captivate the imagination of scientists and space enthusiasts alike. From its extreme temperature differentials to its rugged surface and unique orbital dynamics, Mercury offers a wealth of insights into planetary formation and evolution. The past and ongoing missions to Mercury have provided invaluable data, yet there is much more to uncover. With the potential for future exploration and advancements in space technology, we are poised to deepen our understanding of Mercury's secrets and expand our knowledge of rocky planets within our solar system and beyond.